introduced in the gravitation chapter. If this is a surface of the earth, I'll throw a stone that one. Let me throw a stone. Tomorrow we'll discuss still more better numericals. Now today just I wanted to give the small idea like, now this is a earth. Mass of the stone, let it be m. Now what is the maximum height attained by the stone? I'm projecting at an angle theta, you can see it. How do it will move? Sir, what is their projectile motion? But here what happened? Here you have to take the effect of variation of gravity also. You can't just write a maximum height answer like a v naught square by 2g. G is variable, no, here. Or don't do like this, huh? Don't do like this. V naught sine theta o square by 2g. So there's a maximum height. We are in gravitation chapter. So how do I come to know like this question belongs to gravitation or general kinematics? If they give the value of the conditions like this, radius of the earth, orbital speed or something, no, it belongs to the gravitation. In general, otherwise it should be kinematics one. So don't write this one. No? First of all, how the path? Yes, the path of this stone will be going to go ein, not exact shape. And this is that maximum height. At maximum height, how the velocity of this will be like this. I'm asking this h max, huh? And it is projected at an angle theta with horizontal. How to get this h max? Again, I'll apply conservation of angular momentum. About what? About the center of the earth. Now applying conservation of angular momentum, mv naught sine theta into r should be equal to mv h max plus r. About, so what is this? Conservation of angular momentum about an axis passing through center of the earth. Okay, mass of the particle is m, so that will get eliminated. So v naught sine theta r equal to v into h max plus r. Equation 1. I need one more equation. What is one more equation? Conservation of mechanical energy. So applying that, minus mass of earth m r. Initially it's at this particular point, no? Interaction potential this much. Finally m v naught, or shall I write v naught sine theta or only v naught? Kinetic energy, the theta should not come. Agreed? H max plus r equal to m v square by 2. How many unknowns are there? V and h max. V and h max. Solving these two equations will get the required answer. Sir, now you have to ask question, sir. On what basis you are claiming that the path will be like this only? So just take help of the small ideas. So here the weight, how the weight will act. The weight mg and the velocity v naught. So it should deviate. Again at this particular point, how the weight, the force will act like this, no? And the velocity. So it should deviate. So there's a, I think you must know how to trace out the path also. It's not that something you're going to blind guess you'll make it. You should have enough kinematics approach if this is thing. This the path is what I'm proposing here. Now at various points, when the particle at various points, how the force will be like this. I think we should try with this method, no? What is this F3? It's like a gravitational force. Better don't call weight. Weight means usually we measure on the surface of the earth. Better say gravitational force. And how the velocity will be directed? The velocity will be directed like this. V2, V3, here V0. Because of resultant of F1 and V0, it will deviate. Because here, because of V2 and F2, it will deviate. Because of V3 and F3, it will deviate. And look at this one further. Because of F4 and V4, it should deviate. It should bend, no? The resultant should be like this. It should not be like this. Should be like this. So like this all happen, you should verify the path. Okay, fine. It will be like this here. Then apply conservation of angular, conservation of mechanical energy. Conservation of angular about what point? About the center of the earth. Because about that point, because you see that one, about center C. The force will intersect axis of rotation. So therefore, angular momentum is considered about an axis passing through center of the earth and perpendicular to plane of motion.
Sir? Sir?
Ah.
Sir, could you scroll up one? Yes, sir. Sir, here, shouldn't it be MV naught cos theta, sir?
Theta. Okay, this one. What theta? I took horizontal. Okay, fine. If theta vertical, it would have been MV naught sin theta. MV naught cos theta will come. Yeah. So there's a maximum height ascended. So in projectile motion, it should be like this. So what you have to do is here, the questions all revolves around what? Conservation of mechanical energy, conservation of angular momentum. Finish or nothing big. You have to just focus on only on those ideas. I'll give one more because everything I'm showing